going to start. Okay, so what we're going to be learning for today, we're just going to be learning how to work out what's called product of powers and quotient of powers. Who can remind us, what does product mean? What operation are we discussing when we say the product of something? Say it. Multiplication. And quotient means what operation? Division. So what they mean, product of powers, means that you are multiplying two powers together, or three powers together, or seven powers, however many powers together, which is a base and an exponent. If they say quotient of powers, it means that you are dividing different base and exponents. Now, when we follow this rule, product of powers, let's take a look here. If I were to map this out, meaning I write it out longhand, expanded form, and then simplify it. So for here, I've got 2 to the 4th. There we go. This portion right here says 2 to the 4th. If I write this out in expanded form, that looks like 2 times 2 times 2 times 2. And then I'm multiplying it, because that's what this little symbol right here means. It means I'm multiplying it by this power, 2 to the 5th, which would be 2 times 2 times 2 times 2 times 2. That's the longhand method of writing it out. If I wanted to go ahead and rewrite this answer into exponential form, the base would be 2, and what would the exponent become? 9, right? If we count these together, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 of these values here. So this would become 2 to the 9th. This is the only time I'm going to show you with a variable, because I just don't want you guys getting confused. It's the same thing. If I have x to the 2nd, then that means what I'm writing is x times x, and then multiplying it by the other power, which is x to the 4th. Vincent, I hope you are writing this down. We've got x times x times x times x. So what is my base? For the power, what's my base? X. And then what would the exponent be? 6. So here, I can work this out longhand and write them in expanded form and then simplify it, or I can follow a simple rule. What do you guys notice between these exponents and the final answer? These exponents and the final answer. What do you think I did with the exponents, Angel? It adds up. Did my base change? Did I do 2 times 2 and get a base of 4? No. My base stayed the same. So if I have the same base, all I'm going to do is keep the base the same and then add the exponents together. Okay? So let's write the rule down. When you multiply, so if you're multiplying your powers and they have identical bases, meaning they are both a base of 2, or both a base of -9, or both a base of y, okay, your bases are the same. You multiply powers of the same, here, let me zoom out a little bit so you can see it, of the same base, then all you're going to do is add the exponents. And you're going to keep, I'm going to put that in capital letters, keep the base. The base will not change. You're not going to multiply the bases together. You're going to keep the base exactly as it is. The only thing that's going to change is the exponent. That's it. Sometimes it's going to ask you, hey, simplify this into a single power, which will have just a single base and an exponent. Sometimes it's going to ask you to evaluate thoroughly, meaning that once you've simplified it to a single base and a single exponent, then you find out what that equals. So if, for example, 2 to the 9th, if we were to evaluate it, then we would need to actually find out, well, what does 2 to the 9th equal? So 2 times 2 times 2, and keep going until you get a single number, okay? So what we're going to do here is, again, we're just going to practice a couple of these. So I have 5 to the 3rd times 5 to the 7th. Again, they have identical bases. Their bases are exactly the same. They both have a base of 5. So that means I'm going to take the base and just write it right here. Not going to multiply those bases together. It does not become 25. It stays 5. All I'm going to do is add these exponents together. So I'm going to do 3 plus 7. What is 3 plus 7? 10. So this becomes 5 to the 10th power. Okay? So right here, what I just did is I simplified. If they ask me to simplify, that's what it is when it's in simplest form. If they ask me to evaluate, then that means I need to figure out what 5 to the 10th power equals. So then in my calculator, I can type 5. Which one of these buttons will make an exponent again, guys? The arrow. That arrow button will make an exponent, and then I type in the 10 and hit enter, and there's my answer when I evaluate it. It's going to come out to 9,765,625. That's what it is if I evaluate my answer. Okay, simplify your answer, evaluate your answer. Now don't forget, if we have negatives involved, negatives that are inside parentheses mean that the negative is included with the exponent. Okay? So this is not just 6 to the 4th power, it's a negative 6 to the 4th power. This negative 6 doesn't have an exponent written, but what do we automatically know exists there as our exponent? A 1, an invisible 1. So I'm going to go ahead and put parentheses around it and put a nice lovely little 1 in the corner. So again, I'm going to keep my base. My base is not going to change. I'm going to keep the base as negative 6, and I'm going to put it in parentheses. I have to put it in parentheses. If I don't put it in parentheses, it can change the answer. And then I'm going to add my exponents. What exponents am I going to add together? 4 plus 1. We're going to take the 4 and the 1 and add those together. That's going to come out to negative 6 in parentheses to the 5th power. There's my simplified answer. Okay, that's what I get when I simplify it. If I want to evaluate it, then I need to plug that in. I have to put parentheses, negative 6, close my parentheses, hit my exponent button, and type in a 5. And there's my final answer. My final answer is negative 7,776. Okay, you need to be able to know how to do both simplifying and evaluating, so that way whenever it asks you to do one or the other, you'll know what to do. I want you guys to go ahead and try problems 3 through 5, just 3 through 5 on your own. All right, let's take a look at problem 3, 4, and 5. Let's go ahead and focus on problem number 3. Number 3, the base is negative 7, so we're going to keep it as negative 7 in parentheses, and then we're going to take the two exponents, 2 and 5, and we're going to add them together. That means our final answer should be negative 7 to the 7th power. Okay, that's our simplified answer. If we were to evaluate that, negative 7 raised to the 7th power, negative 7 raised to the 7th power is going to come out to a negative 823,543. Okay, you could have both of those answers, simplified, evaluated. Simplified and evaluated. For problem number 4, our base is a positive 2. For our exponents, we're just going to add the 4 and the 5 together, which we already did before previously. That came out to 2 to the 9th power. That is our simplified version in exponential form. Then if we simplified it, evaluated it, it would come out to 512. You need to have both answers in case they ask you for one or the other. Problem 5, we're only going to simplify it because evaluating it with your actual calculator, you'd get scientific notation, which is a different way of writing really, really large numbers or really, really small numbers. But our base is 12. Our base is 12. Our exponents are 9 plus 2 plus what? 1. So 9 plus 2 plus the 1 means that we're going to have an exponent of 12. So 12 to the 12th power. We're just going to leave it in that format. Now, the reason I didn't want you guys doing number 6 is because if you notice, do I have all the same base? No, I do not have all of the same base. So I've got a base of 2 that has an exponent of 3 and an exponent of 2. But I also have a base of 3 where it's got an exponent of 5 and 9. So when I am working this out, I have to do them separately. So we're going to start with the base of 2. We have 2 to the 3 plus 2 power. Then we've got 3 to the 5 plus 9 power. So when we work that out, that becomes 2 to the 5th power and times 3 to the 14th power. And there's our final answer. Okay, if they wanted you to evaluate, that would be fine. Okay. Take a look at problem number 7. So for problem number 7, I told you guys yesterday, it's very important, or not yesterday, on Monday, it's very important that when you are dealing with fractions and negatives, you have to make sure you put them inside of those parentheses. So all of these have a similar base. They all have a base of 1/3. Just make sure that you are writing 1/3. Stop talking. Inside of your parentheses, and then like previous, since it is a product, you are taking the exponent and adding those exponents together. So 3 plus the 5 plus the 1, that's going to come out to 1/3 in parentheses to the 9th power, because 3 plus 5 plus 1 gives us 9. We're not going to evaluate anymore because I want us to get us moving on, because we are going to do a live quizzes today for our assignment. Let's take a look at problem number 8. Problem number 8, we've got several different bases. To step, move back. You've got -4/5 as one of your bases, raised to the 8th power and to the 2nd power. So you're going to write -4/5 in parentheses. Outside the parentheses, your exponents are going to be 8 plus 2. Hurry up. Your other base is a +7. So you're going to write 7. And then the exponents, for the first one, your exponent is a 1. And then the 2nd power, your exponent is a 2. So you're going to do 1 plus 2 for your exponents. Your final answer is going to be -4/5 inside of parentheses to the 10th power. And then multiplied by 7 to the 3rd power. And that's your final answer. Okay, so that's how we deal with product of powers. We keep the base, we add the exponents. What do you think we're going to do with quotient of powers? If we keep the base and add the exponents for product, what do you think we're going to do with quotient? Subtract. We're going to subtract them. So go ahead and turn your paper over to the back. So with quotient of powers, because it's a division problem, just like we did before, hey, we're looking at the fact that they have the same base. That means I've got 2 times 2 times 2 times 2 times 2 times 2 times 2, because it's 2 to the 7th power, over, for here, 2 to the 4th, I've got 2 times 2 times 2 times 2. And we know that with a problem like this, for every value we have on top, if we've got an identical one on the bottom and it's all multiplication, you can just cross them off. And so what we're left with is 2 to the 3rd power over a 1. If there's nothing remaining on the bottom, we know there's always an invisible 1. So you can just write this as 2 to the 3rd power. So notice again, we take 7 minus 4 and it gives us our exponent of a 3. Same thing for here, x times 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 x. We've got x to the 9th. We've got 9 x's at the top. And on the bottom, we're just going to have x times x. And we can simplify it. We can cross off those. We have nothing remaining on that bottom. So that means our answer is x to the 1, 2, 3, 4, 5, 6, 7 power. Or you could just subtract 9 minus 2 and get 7 for your exponent. So like we did before, when you were multiplying, you added the exponents. When you divide, if you happen to be dividing powers of the same base, then you subtract the exponents. And again, you keep the base. The base does not change. The base stays exactly as it is. We did not do 2 divided by 2 to get a 1. Our 2 stayed the same. The base remained the same. The only thing that changed was the exponents. Okay, so let's take a look at problem number 1. Our base is negative 7, and it's inside of parentheses. So we're just doing negative 7, and we're going to subtract the exponents, 9 minus 6. So that's going to come out to negative 7 in parentheses to the 3rd power. Okay, if you happen to have several different bases, then again, you only subtract exponents of like bases. They have to be identical bases. Let's take a look at problem number 2. We have 8 to the 8th over 8 to the 6th. What's our base going to be? 8. Okay, and then we're just going to do 8 minus the 6. We're just going to subtract those exponents. So we get 8 to what power? We don't say to the 2 power. We say to the 2nd power, or 8 squared. Okay? For problem number 3, we have 2 different bases. So again, we're focusing on each of the problems separately. Thank you. We're going to focus on each of the problems separately. So we're going to focus on 6 to the 4th over 6 to the 2nd. That means we're going to do 6 to the 4 minus 2 power, which will come out to 6 to the 2nd power. And then we've got these negative 3's as our bases. So we'll have negative 3, and then the exponents that we're going to subtract here are 5 minus 2. And that comes out to negative 3 to the 3rd power, or negative 3 cubed, and there's our final answer. Go ahead and quickly do number 4, 5, and 6. right, let's go over this real quick. I'm not going to use all the different colors for showing you the base and the exponents because this one has 3 different bases, so I'm just going to do them as one. Here we have 3 to the 4th over 3 to the 2nd. That means we're going to do 3 to the 4 minus 2 power, which would come out 3 to the 2nd power, or 3 squared. Then we move on to 5 to the 10th over 5 to the 8th. That means we're going to do 5 to the 10 minus 8 power. That comes out to 5 squared. And then we've got the 2 to the 5th over 2 to the 4th. That means you're going to subtract the 5 and the 4, and that just comes out to 2 to the 1st, or just 2. It doesn't matter how you want to write it. If you want to put the exponent of a 1, that's perfectly fine, and there would be your final answer. For problem number 5, you have both product and quotient. You have both product and quotient. So I'm going to go ahead and do the product up here first. That means I'm going to add my exponents. I'm going to do 4 plus the 2 first, which would come out to 3 to the 6th power. And then I can go ahead and subtract these exponents. And that would be 3 to the 6 minus 2 power, which is 3 to the, 3 minus, or 6 to the minus 3rd power. I miswrote here. That would become 3 to the 3rd power. Okay, so your final answer for number 5 should be 5 to the 3rd. For here, again, you could either do quotients first and then products, or you could do products first and then quotients. I'm going to go ahead and do quotients first for each of these. 4 to the 10th over 4 to the 6th means I'm going to do 4 to the 10 minus 6 multiplied by 4 to the 7 minus 4th power. 10 minus 6 just comes out to 4, and 7 minus 4 just comes out to 3. And now I have a product problem, so I'm going to add the 4 and the 3 together to get 4 to the 7th power. Okay? What I need you guys to do right now is you're going to log in quickly to Google Classroom. We are starting a live quizzes. Live quizzes. Get in. You have 3 minutes before I start it, and once I start it, if you can't get in, it's going to go ahead and lock you out. 3 minutes to get in.